Hi everyone, welcome to today's workshop. And today we are going to learn more about structure and check out some of the code of the Polkadot blockchain. And today I will be hosting this workshop and people. So thank you for joining, and I hope that you will learn a lot and maybe like to have more interest in the Polkadot ecosystem. Polkadot, let's first let's talk a little bit about the history of Polkadot. Polkadot one is introduced the relay chain, which utilize the Aave or one pair or consensus mechanism, and was based on substrate. The ecosystem comprise a separate responsibility ecosystem for the substrate and the Polkadot relay chains and Cumulus. It also features the Polkadot.js API, link backing, and the first version of governance, Gov1. The project was supported by Web3 Foundation grant and Parity employees. And then we with Polkadot 2.0, the architecture involved to use a monorepo structure for the SDK. The feature includes the small dot-like client, asynchronous banking, OpenGov, and Agile Core Time. The new version also introduced fixed factor and elastic scaling, Cumulus, Pass, and a treasury system alongside a salary fellowship. Oh, by the way, uh, if you want to check out more about the Polkadot Fellowship, you should just type Google like Polkadot Fellowship and you'll see like the ranking, how to join, and also like with a lot of information, like very good information. Polkadot Jam represent further evolution with the Jam chain, utilizing safe sharp rope and grandpa consensus mechanism and multiple implementation. Notably, it shift from WAMS to Polka VM and renamed Parachain to Core Chain. The SDK and runtime components are also rebranded and restructured to improve performance and integration. And also, Polkadot Jam also like expect to be in around Q2 of 2025. So right now, we are in Q1 of 2025. So like it's expected to be like very good, like very like new evolution for Polkadot. Uh, Polkadot Play focus on the core Play Jam service and SDK. It explores adding sequencing and hard dependency as Jam facility and consider moving some system parachain to Jam service for better modularity and efficiency. In the future, Polkadot aim to enhance scaling capability, potentially supporting 2046 and more nodes with parallel accumulate and OL style multi-chain bridge. Quantum resistance is also a focus to ensure long-term security and efficiency. For now, our focus is on Polkadot 2.0, its component and its integration. Let's dive deeper into the overview and the CI/CD process that supports the development and maintenance of the Polkadot SDK. Here is an Overview of how the component of the Polkadot SDK work together. A substrate-based chain consists of a runtime, which is the application logic, and a node, which handle everything else. Parachain are special substrate-based chains that have been made Polkadot aware using Cumulus. And GitHub CI/CD also play a crucial role in Polkadot development workflow. This diagram summarizes the interaction between various components of the Polkadot SDK, ensuring seamless integration, testing, and deployment. The diagram illustrates on how of the key component of the Polkadot SDK work together to form a substrate-based blockchain. The subject node library supports the node which handle network communication, transaction processing, and other critical functions. Meanwhile, the framework for runtime acceleration of modularized entity is used to build the runtime which contains the application logic of the blockchain. Together, this component enables the creation and operation of a robust, flexible blockchain system. A substrate-based chain is a blockchain composed of a runtime and a node. The runtime is the application logic of the blockchain, handling the rules and behavior of transaction and state changes. The node encompasses everything else, including networking understanding. You can refer to the Great References doc forms meta protocol documentation. In this context, the runtime is built using frame, while the node is construct with the rest of the substrate. Parachain is a special substrate-based chain where both the node and runtime Polkadot means that the parachain Polkadot relay, leveraging the probability. Diagram illustrates how the frame are effectively within Polkadot relay. Parachain is a special substrate-based chain where both the node and runtime diagram illustrates a library, node library form a parachain. The integration library enable providing shared security probability. Stable release of .SDK had during this period no breaking the stability. This will regular updates every 2 which include security patch, common improvement, and new non-breaking feature. This approach ensures developer consistent and development of chain. 90 release of the box SDK every night. These releases are intended testing and as such include breaking change, versioning of the this is 0.0 last 90 the month indicate the specific night to allow them update immediately. A buy with standing stable. The Polkadot SDK version manager upgrade how it you can use .psv which SDK ensuring compatibility different projects and the let's move very high aspect and future. One common question is why did we responsible responsibly consolidation groups and document.io which are still a give you minus.io develop. Question is which repository have been following repository have been created in people by development. Molus substrate and population flow by ICT repository. Sometimes Polkadot host fellowship is critical part of it. Here we can see the structure of the repository is organized, which each component is in efficient .NET management and slide shows the structure directory sepsis update .NET indicate organize path to the Polkadot SD trees Polkadot then on is a custom and navigate to the various which for example visit example agree from the repository. You can do this by running that frame example .sh repository. This direct utilize in the example like this. App mode. This example are actually I use provide valuable capability and flexibility of this cargo that Tom finds in the Polkadot SDK. Consistory defines a dependency and configuration example in substrate framework. Here we see configuration for example such as basic frame create kitchens and work. This entry specifies a path to the example and to this configuration crucial for maintenance and ensuring that a example can run in the high slow, high short SDK slash example slash short palette is unknown ever which you auto generate to our configuration ensures that it includes necessary default excluding any setting palette no default. This approach helps quickly sync and split directory within the example SDK. My comprehensive example effectively the kitchen Polkadot SDK include a wide range, making it ability right. On the other hand, the split example found with Polkadot's same examples dot demonstrate how to split and manage different framework, including modular development example that we can see how different sections are important. This practical selection, bringing the event rural approach allow for creating the revisit basic example. For example, the AI and structure common frame run can find in the basic class example. Use a document on the computer minus my package as one. Example serve as a educational directory structure include free code providing a tip overview, setup, and to ensure that the basic example palette functions correctly. Run the test in Qt. This can be done using net example basic. The basic directory verified within the palette. This step is crucial for maintaining the quality. Understanding the test with palette example to graph library is a test file created at Polkadot. OK team. This building this behavior. Take a closer look at the example dot get function demonstrate how to the pop. In this test, we initialize a check that the value is correctly verifies that the accumulation correct and show that function even put OK and as equal. We validate our palette shape in different scenario. Understanding this can help you ensure continue with our solution. Polkadot SDK. Just frame example and it will ensure that default value are shown within. Step include initialize assets init using state data value. The things as assets default value are correctly relation affected. Reviewing test case as any for reliability test case from function set dummy work correctly. This test case we indicate the test value 133. The set dummy function is set value. We use the access faithfully. Asset equal macro the value is correctly set as well. That ensures that the set dummy function ended setting greatly. Writing and reviewing SK is crucial. Really, next we have more complex test state name 9xy palette example in Polkadot SDK. This case we start setting up new test execute A call to the set dummy function is created to also dispatch the assert equal the watch dummy size extended with a specific priority maximum counted to 60. The assert equal echo set and the priority set to 250. The validation failed with an invalid transaction result error that ensures that the watch dummy has in a different priority value, which is essential for maintaining validity within the substrate framework. Now let's look at the counted map work test function from the palette example located in the test class. Function demonstrates how to work map data structure the number. In this test, the test environment is set up with using new text with the init, the counted map test map is the an entry is inserted into we verify for yet effect test and shows us it's crucial for many within the runtime. Now let's export the default config Polkadot SDK directory contain a default configuration allow developers to specify this configuration and into in the default config specify the Rust source asset and example references understanding and history. Now let's take a closer look at the and Paco MD lastly and Rust highways user doc Paco dog pack last package enjoy agency when develop blockchain. On this slide, we are diving into how config examples, especially the test function short-lived The example demonstrates how to test default configuration within a search frame. The function it works is your primary test function here. Start by importing the necessary trait and configuration from frame support and our palette. First test asserts that the value type that is not written remain as expected. Assert equal the default value as you test it. Next we test values that have been overwritten match the expected new value. Expect equal runtime task config overwritten default value expected 278 U32. You also assert that type ID for non overwritten and overwritten types match the expected resource. Assert equal std and type ID of runtime with default type d and with default type assert equal std any type ID of overwritten type as type ID. This testing approach ensures that default customization type is behave as expected within the runtime. The powerful way to validate operation is expecting. Understanding this really helps you. You need to validate. Now let's shift our focus, especially it includes live setup tests and meant for production use it as it bypass some of the rigorous check production environment. The structure of the depot includes cargo, document, live open. Remember demo is an testing. In this dive deep demo guide document this with slideshow to ensure various expected behavior. Expected behavior of the add dummy function in different scenarios. Initially, the dummy storage item is asserted to be none. The value is when then added, and the test checks if the value stored correctly. Further, it tests the accumulation of value to ensure multiple entries are handled properly. Testing is a critical aspect of development, particularly in blockchain environment where security and correctness are paramount. The demo example palettes provide a simplified environment to understand and verify the functionality of your code. The slide showcases another test function from the demo example palette in the Polkadot SDK repository. The function setDummyWork is annotated with test, indicating that this is a test function. The test environment is set up using new test.execute, providing a sandbox for testing. Within the test value test file is initialized to 132. The function setBar is called with runtime origin size 1 and the test file simulating size transaction. The assert OK macro ensures that the setBar function executes without error. The assert equal macro verifies that the value stored in bar matches the test file. Testing such functionality is crucial to ensure that the storage and retrieval mechanism in the blockchain operate correctly. This helps prevent potential issues that could compromise the integrity and reliability of the blockchain network. This slide introduces the Off-chain Worker example palette from the Polkadot SDK repository. Off-chain workers are a crucial part of the Polkadot and subject ecosystem, allowing the execution of tasks that are not feasible to perform on-chain due to resource constraints. The off-chain worker example palette provides a simplistic oracle for the BTC/USD price, which is triggered after every block. The on-chain logic accelerates the resource and stores the last 62 values to compute an average price. The palette contains several key components. Cargo.tone for specified dependency. readme.md for documentation. The source directory containing lib and test. The lib includes the main logic of the palette and the test contain test case. The palette demonstrates how to use both signed and unsigned transactions to test and update data. The logic in Off-chain Worker OCW includes mechanisms to prevent network spamming to ensure only one unsigned transaction is active at a time. Running the example done using Polkadot minus package minus example minus Off-chain Worker minus open. This palette is for demonstration purpose and is not meant to be used in production environment. It provides valuable insight info on how Off-chain Worker can implement it as within the substrate framework. Let's take a closer look at for the test for the Off-chain Worker palette. Testing is a crucial part of developing any blockchain module to ensure that all functionality works as expected and to prevent future bugs. The test function it aggregates the price verifies the price aggregation logic of the Off-chain Worker. SP-IO test functionality execute set up a default external environment for the test. Initially, the average price is checked to be none. Assert OK example submit price runtime origin side test bar simulates submitting a price of 27 and check that the submission is successful. After the first price submission, the average price checked and should be 24.7. The process is repeated with a second price submission of 43 and the average price is calculated to be 35. This step validates that the Off-chain Worker correctly accelerates price submitted to it and the pilot logic works as intended in an isolated test environment. Next, let's examine how the Off-chain Worker palette handles HTTP calls and pass the resource. This test function should make HTTP call and pass resource is designed to verify that the off-chain worker can correctly make an HTTP call and handle the response. The test function should make HTTP call and pass result begin by setting up the testing environment using test off-chain. New test externality default is used to create a default test environment. The off-chain worker extension is registered with T dot as register extension. Off-chain with off-chain worker is new off-chain. The function prior oracle response is called to mock a response from the prior oracle. Inside T dot execute with the test executes the code to be tested with let price equal example fetch price unwrap simulate fetching the price from the off-chain worker. Assert equal price 50,523 verify the fetch price match the expected value of 15,500. This test ensures that the off-chain worker correctly makes HTTP calls, handles the responses, passes the data, which is critical for the functionality of off-chain worker in a blockchain network. Continuing with the off-chain worker palette, let's take a look at how we can mark several HTTP call for the testing purpose. This test function knows how to mark several for HTTP call. Demonstrates the process of marking multiple HTTP requests and verifying the response. The function knows how to mock several HTTP calls, set up the test environment using test off-chain news and test externality default. The off-chain worker extension is registered with T.register extension off-chain worker to off-chain. Multiple HTTP requests are marked using state.write.expect request. Each expect request specifies the method gets the URL and the expected response. Inside the test execution block, the fetch price function is called multiple times to simulate fetching price. Assert equal is used to verify that the fetch price matches the expected value 100, 200, and 300. The test ensures that the off-chain worker can handle multiple HTTP requests, correctly mark response, and accurately process the data. It is crucial for maintaining reliability and correctness of the off-chain interaction in the blockchain network. Now let's dive into how to submit a signed transaction on-chain with the off-chain worker palette. This test function should submit signed transaction on-chain, illustrates the process of fetching a price, signing a transaction, and sending it on-chain. The function begins by setting a memory phrase count phrase, which is generates a key pair. The off-chain state and transaction pool are initialized using test off-chain new and test transaction pool new. The key pair generated are 25519 generate new. The test environment is setting up use test external for various extensions are registered. Off-chain worker as transaction pool key store. The test mark a response for the prior oracle using prior oracle response. Inside test execution block, the function fetch price and send sign is called to fetch the price and send the signed transaction. The transaction is then read from the pool and decode. Entries decode. Assertions are made to verify the transaction was properly signed. The code contains the contract function and price value. That ensures that off-chain worker can securely fetch data from external source, sign transaction, and submit them on-chain, maintaining the integrity and authenticity of the data. Continue our exploration of the off-chain worker palette. Let's examine how to submit a raw unsigned transaction on-chain. This function to submit raw unsigned transaction on-chain demonstrates this process by simulating the fetching of a price and sending an unsigned transaction to the blockchain. The state initializes the off-chain state and transaction pool using test off-chain new and test transaction pool new. A key store is set up in memory key store new. The test environment is initialized using test externality default. An extension are registered for off-chain worker transaction pool key store. The price oracle response function is marked to return a price and when called. Inside the test execution block, fetch price and send raw unique gain is invoked to fetch price and send an unsigned transaction. The transaction is then read and the pool and decode using exchange code. Assertion verifies the transaction is not signed. Each transaction is none. Code includes the correct function and the price value. This example highlights how off-chain worker can efficiently perform operations that do not require signing, which can be useful for various applications such as price feed or other external data sources. Off-chain worker palette passing price. Lastly, our exploration of the chain worker palette. We focus on passing JSON data to extract price information. This function pass price work demonstrates how to validate optimization and code price data. The pass price work function set up a vector test data containing JSON that expected pass result. Each JSON string represents a price value in USD with variation in format and content. The state iterates over the test data vector, passing each JSON string using the example pass price function. Assertion verifies those match the value. Emphasize the importance of robust pass in off-chain worker as they often deal with external data resource. Highlights the different case handling the test data such as extract price, rounded value, and invalid data. Explain how these parsing functions contribute to the overall reliability of the off-chain worker functionality. This example reinforces the need for thorough testing of all components in your off-chain worker, ensuring accurate data handling and processing. Now let's explore the concept of splitting a palette in subtract. This slide provides an overview of basic examples that demonstrate how to split sections of a frame palette across multiple files. The directory structure shown here includes several trust files like benchmarks, sleep, s, and weight. Each file serves a distinct purpose, separating concern and organizing the palette code base effectively. The purpose of this approach is to enhance modularity and maintainability, especially as the palette complexity grows. The code this example encourages developers to consider modular design principle when building complex palettes in Substrate, promoting better code organization and easier maintenance. On this slide, we see an example test case for the split palette located in Polkadot SDK substrate frame mixing this test. This said it works for default value, demonstrate how to verify the functionality of the palette when a default is set. The test begin by setting up new test extension with new test execute and move to the path genesis log block by setting block number to 1 and assign extrinsic is dispatched to the do something function, simulating an action by the runtime origin with a value 42. The palette storage is read to check that expected value 42 has been correctly stored. Finally, the test asserts that the correct event something stored was deposited with the expected data. This approach helps developers ensure that their palettes are robust and the changes do not include regression. On this slide, we have a test case focused on error handling with a speed palette. Test located in the Polkadot SDK slash subtract slash frame slash example slash split slash source slash test is named correct error for non-value. The test starts by setting up a new test extension using use test execute. The purpose of this test is to ensure that the appropriate error is thrown when no value is present. This uses the assert no macro to verify that the function caused error from the embed palette failed as expected. The error is non-value. This approach to testing is not only verifies the function but also ensures that the system can handle unexpected scenario gratefully. That would be the end of today's workshop. For listening, and I hope see you in the next one.